fellow skyscraper is going to report out or get us to think about things that we can't necessarily explain that we see in the sky. I took interest in this when I read the description. How many of us here, in the course of our observing, have seen something in this? I don't mean a UFO, I don't mean alien, I mean just something in the sky for which we could not get an explanation. My hand is up too. Okay. All right. Well, we can talk about those later. I hope we can. But in the meantime, please help me extend a warm skyscraper welcome to Steve.
Hello, everyone. Is the microphone working? Can you hear me all right? Just to expound on what he had just mentioned about seeing things in the sky that you can't quite explain. How many of your friends have reached out to you when Venus is low on the horizon and have to do with the astronomer? What's that real bright light I see? Is that a UFO? You know, what's that? You know, people send me a text message. What's that bright light low in the east right now?
Oh, Sirius.
A Sirius or a Jupiter near the moon. What's that near the moon? People are curious to know what they're seeing. And a couple of more recent instances of that. Just last Saturday night, I was at a cookout and I was sitting at a birthday party for an adult. You know, we still play kid in the tail on a donkey and all that. But I was at a cookout outside and I saw this strange glowing light in the sky. And I was up in Walpole, Mass, which is not far from the flight path of Logan Airport. And I thought I was seeing the lights of a jet and whatnot. And this was last Saturday night around 7:15. The next day, one of our club's very own members, Steve Hubbard, posted a picture and said, and I think it was from here. I think it was from outside here. There was a SpaceX rocket launch, and the plumes could be seen like spreading the exhaust, and it was releasing some Starlink satellites. And people were curious. Like, everybody was curious, what the heck is that we're seeing? I didn't know what I was seeing. It wasn't really announced ahead of time. I didn't see any notice of that. And I was sitting in a Adirondack chair, drinking a beer, looking at the sky, saying, what the heck is that? You know, and then the answers kind of came out. Many of you saw that last Saturday night?
Yeah, we did.
Yeah. Another phenomenon that's recent is when these Starlink satellites are first released, they usually release like 40 or 50 of them from, you know, with these payload. And then when they're first released, they're pretty close together in the sky, and they move across the sky and reflect sunlight in a line, like a perfect line moving across the sky. And people are like, what the heck is that? You know, when you see it, it freaks you out. And I think curiosity is part of the nature of being amateur astronomers. You know, we see things that we expect to see through a telescope, but sometimes there's stuff that we don't expect to see. And that's the point of my talk here tonight, is to question the things that you don't expect to see. Like, back up for a minute, say, hey, what is that? And then explore it a little bit, and you'd be surprised what you find. And that's what I'm going to talk about tonight. I've kept a little bit of mystery of what this topic is. You know, that's to get the crowd excited. and I think this is going to be a kind of a fascinating, fun talk. I don't mind being interrupted with questions. If you have questions on the way, feel free to chime in. But I'm just Joe's amateur, a lot of mass. How's that? A little feedback?
Is that microphone off?
Yeah, that one's off.
All right. Yeah, better? Okay, we're good. So I'm going to move right along. Again, feel free to raise your hand along the way and ask questions. And I'm going to tell you the story about a backyard astronomy discovery. So it started when I was 14 years old, in 1978. And I was a kid. I used to play outside. It's not something the kids do much of anymore, but I used to play baseball all the day in the local field. And when I would head home, when the street lights came on, you know, it's time to head home, I would often see this bright light by itself, this bright star by itself, right up there. Maybe I should use the pointer instead. It might be easier. right up there, this one lone star by itself, night after night in the western sky. That kind of got my curiosity. You know, I'd start out running home and then I'd stop and I'd look at that and say, what is that? And I'd look around and I wouldn't see any more. And my curiosity got the best of me. So I went into the house, got my dad's binoculars, went back outside into the driveway and aimed the binoculars at this star in the sky. And lo and behold, I noticed that this star all of a sudden became a little crescent moon, like a little backwards crescent moon shape. I didn't know what to make of that. I looked at some of the other brighter stars in the sky and they all appeared as pinpoints of light. But this one particular one had this crescent shape to it. And my curiosity was really peaking at this point, and I had to know more about what I was seeing in the sky. At this time, I had no interest in astronomy. It wasn't really something that occurred to me as a hobby, but this particular object got my interest going. So the next day, rode my bike the 3 miles to the Rainham Library, Rainham Public Library, about 3 miles from my house. I went into the Dewey Card catalog and found that all the astronomy books are in section 520. You all know that, right? Any library you go into, go to the 520 section and you'll find all the astronomy books. So I went through the astronomy books, but that wasn't very helpful. But I did go into the monthly periodical section and I came across the June 1978 issue of Sky and Telescope magazine. There's a copy of that issue here. I leaf through the center. The center has a pull-out star chart, and it also has what you can see in different areas of the sky at different times of the evening. Lo and behold, my jaw dropped when I read what was inside the middle section of this magazine. I got on my bike, sped home, threw open the front door. It's a Mom, Dad, I discovered Venus, right? Right there, I could see it every night, you know? I was thrilled with this finding, you know? Up until then, the only way I thought you could see a planet was if you were Marvin the Martian on Bugs Bunny looking through a telescope, you know, with the big eyeball appearing at the other end of the objective. You know, you look at one end and the eyeball blinks at the other end. I thought that was the only way that you could see a planet. I didn't know that you could stand in your driveway and see another planet. I thought that was the coolest thing ever. I discovered Venus. Thank you for coming. Have a good night. Any questions? No? You want more? But wait, there's more. Who said that? What was his name? The guy said, but wait, there's more.
Ron Popeil.
Yes, yes. But wait, there's more. We're going to go into my time machine. We're going to get into the time machine and we're going to travel to 1999. Does anybody remember 1999? Few of you? Prince remembers 1999. He wrote a song that was popular, Party Like It's 1999. We're going to turn back the clock to 1999, 23 years ago now. Some of the things that were popular in 1999. We got Clinton, SpongeBob, America Online. Remember your dial-up internet? Through the phone line, nobody could use the phone for the 4 hours that you're on the internet. Stamps were only 33 cents. We were all panicking about Y2K. Gas was only $1.17. Oh, to go back to those days. Furbies, remember Furbies? You had to get one of those for your kid for Christmas or else Santa didn't exist, right? You had to find one of those things. 1999, we're turning back the clock to 1999. And at that time, I was a member of the Astronomical Society of Southern New England. There's a few people that are cross members here. Ron, right here, is a member of all the clubs. But I was a member of that club. They meet in Rehoboth every month, similar to this club. We meet in Rehoboth, Mass. once a month, and I was a member there. And I had a friend, Dan Silva. He lived in New Bedford. And the thing with Dan is he liked to seek out the most challenging things that you could possibly see through a telescope. He went to Horseneck Beach at 4 a.m. in, I don't know, February, just so he could see Omega Centauri, that globular cluster, rise above the Atlantic Ocean. You know, it's a real southern globular cluster. It gets like half a degree above the horizon for our latitude here. But he successfully saw it and photographed it from our latitude here. We spent a night looking at Phobos and Deimos, the two moons of Mars. We've seen 4 different moons of Uranus. Just these real challenging objects. And he had been over in April of 1999 with a star chart, and he wanted to find 3C273. Some of you might recognize as a quasar in the constellation Virgo. It's a magnitude 12.9 quasar, and a quasar is a extremely luminous, extremely distant, active galactic nuclei. So it's kind of an undeveloped galaxy that's very bright and very far away. So it's the farthest things that we can see with our eye on the telescope here are quasars. They're really far away and very bright. So that gives us a chance to see them. So we found that particular quasar, magnitude 12.9. It was 2.9 billion light years away. That's how far away this quasar was that he found. But that wasn't good enough for Dan. Dan made me circle the calendar. June 18th, we're going to look for something that we cannot see. He's going to come over with a star chart, and we're going to try to find something that we cannot see. So he comes over with a new. Well, first of all, he comes to my little backyard observatory. My observatory at that time was only about 1.5 years old. I built this in my backyard in Bridgewater, Mass. And inside, I have a C11 11-inch SCT telescope on a post, ready to go. So we got decent group telescope power to try to look pretty faint for faint objects. So he comes over with the star chart from Guide software. It's pretty archaic at this point, but he wanted to seek out the most distant object that we could see with our eye, not using any kind of camera. We wanted to find this quasar right here, magnitude 14.6, which is the real limit of an 11-inch scope, considering the light pollution I have in my yard. It's about 8 billion light years away. That's looking back, 2/3 of the way to the beginning of the universe. 8 billion light years is extremely far away. And the thing that I want you to take note of here is this particular wedge shape here. You got a star, quasar, and star. So like this, the stars are my hands, the quasar are my elbows, where my elbows touch. That shape is the theme that's going to keep coming up as I talk. But this little shape right here is what I want you to remember. The only reason that I put Jupiter in this picture, because I wanted to know the size of what area we're looking at here. Jupiter is on average 45 to 50 arc seconds across. So when you look at Jupiter through a telescope, it looks pretty small in the center of the field of view, pretty tiny. And Jupiter would fit between either one of these two, these two openings here. So all in all, we're looking at a tiny area of the sky that's only 2 Jupiter widths across. Very small area of the sky, very challenging area to find. And how are we ever going to see this 14.6 magnitude quasar? So for the next 1.5 hours, we did everything possible to find this area of the sky. This area of the sky is just north of the globular cluster M92 in Hercules. Okay, so it's fairly high up in June. Hercules gets fairly high in the night sky. It's June, there's a first quarter moon in the sky. We kind of waited for that to set, which means we're talking midnight now before we really even got started. We found the area, we found the field of view that we should be looking at. And we spent a solid 1.5 hours just looking with different eyepieces, trying to say, do you see it? I don't quite see it. Do you see it now? How about with this power magnification? We even put duct tape over the red LED numbers of the clock that I had on my observatory. We thought that was too blinding. We put duct tape over everything that we thought might impede or interfere with our light darkness adaptation. So we covered all the little lights on the telescope mount, anything. We put our watches in our pockets. We did everything possible to dim our surroundings. And I even put like hung a sheet in the dome slot to make it darker, just so that we can be as dark as possible to see this quasar. And lo and behold, both of us do agree that we did get a glimpse of this quasar after an hour and a half of trying. So we did successfully see this quasar. We were thrilled with the visual, confirmation that we saw this quasar about 8 billion light years away. So we're looking at photons of light that are nearly twice as old as the Earth itself. The Earth was only 4.5 billion years ago, and we're seeing photons that are almost twice as old. We were thrilled with that. That was with further research, we couldn't find another quasar that was within our visual ability to see that was farther away. So we were pretty convinced that this was the farthest thing that we could see with our eyes. We had another friend in our club. His name is Ed Kuchar. He may have been a member of this club as well back in the day, but he had a 6-inch refractor in his yard. He lived in Rehoboth, Mass. He had a 6-inch Starfire astrophysics refractor, and he also had a Starlight Express MX 916 CCD camera. So he was like a god to us. He had this fancy equipment in 1999 that nobody else had. He had a CCD camera, which is just totally cool. Not too many people had them. And he took it upon himself, after reading our report on the Astronomy Club bulletin board that we posted at the end, and I summarized our observations. He took it upon himself to take a CCD image of the same area of the sky. So there's the little wedge that I was talking about, and the quasar is pointed out right there in the middle, right? Matches the star chart that I showed earlier. It matches what we saw in the eyepiece. Pretty cool, right? End of story. Good observation, high fives all around. We're happy with that, right? No, but wait, there's more. So my friend Dan comes back a couple of days later and he says, Steve, look what I found. He says, I got on the internet and I found this Mount Palomar image, a plate. I don't know if it was a glass plate or what kind of plate it was, but it was taken in March of 1955. So this is a plate from Palomar in 1955. The quasar is circled there. And then we put it side by side with Ed's image right here. Dan took the liberty of rotating it and resizing them to make them the same size and make it a match up. So you got that little wedge shape there, the same little wedge shape there, the quasar. So now we're seeing it side by side. Really cool. So now our story's over, right? No, but wait. So I'm looking at that shape in both of those pictures, right? That shape, and I see something. And I say, what's that? I say, what is that? And he's like, what? And I look right here, that star, see that star? And if you look at it over there, it's not quite in the same position. You see that? You can make that out from where you sit. So what I did is I cropped those, I cleaned up both images, I magnified them a little bit, and I put them side by side. So I put the Palomar archive and Ed's picture side by side, the same size. All I did was try to make them look the same. I didn't move the positions of anything. I tried to make them look similar by pulling up brightness and contrast and whatnot and resizing them to make them look the same. So we have the little wedge in both of them. The quasar is here. But you see in 1955, the star is down here. And then when we observed it, based on Ed's CCD image, the star is almost in a line between the quasar and the star. See that?
That's cool.
See how it's changed its shape? So it's changed its position. So now we're really curious. So our project is not done yet. So I get on a news group. 1999, we had news groups, kind of like a chat room, but it's different. It's just these different topics. In this case, it was science, astronomy, amateur. Like you find a topic and you work your way down to the people that you want to contact with and chat with. So I get on the news group, and I also made a quick website about basically everything that I just told you now with those pictures attached to it. And I tell people that what we have found. I said, in short, we're looking at a distant quasar through a scope. We have a CCD image. We compared the CCD image to the Palomar image, and in the two images, we noticed star that had moved. It wasn't an asteroid, because an asteroid probably would have moved a lot more than that in 44 years. It was 44 years between the two times. I said, we're curious to find out more. We were just seeking other opinions from other amateur astronomers at this point. And I said, visit the website here and tell us what you think. You notice this archaic looking message, right? It looks like teletype. It looks like, you know, the 19. I have all this data saved from 1999 right here on this floppy disk. So all these images, all these emails that I saved, everything related to this discovery that I'm telling you about, I have saved on a floppy disk. Okay. So nobody, don't come near this with a magnet. Do not come near this with a magnet. So moving right along, the first day that I posted this website, I was able to look into this little applet called Site Tracker, and I could see what people were checking into this website that I had posted about this moving star. The very first day, I had almost 200 people hit the website, and they, you know, it shows where they come from, you know, commercial network. Australia, 7 people checked in from Australia. The US government, you know, to see if I owed any taxes. US educational, which I assume is either schools or colleges. Germany, nonprofits, you know, UK, Spain, Netherlands, Norway, Canada. So people were starting to check into this web page, and we were like, we were just thrilled with this. We didn't know where it was going to go, what it was going to find out. Was it a binary star, and that other star was just orbiting around the brighter one? We didn't know. Is it just passing by? What's going on with this star? So a short time after, we had an ASNI meeting, and Dan, myself, and Ed got together, you know, for a photo. This is one of those Instamatic photos, you know, with the Polaroid, where you take the picture and then you peel back it, and then you gotta wait couple of minutes for the colors to come out. That's how old this is. But there's the 3 of us with our moving star discovery in 1999. So this I scanned in and I incorporated it onto that website that I told you earlier. A short time after that, one second, please. I get an email from Phil Plait.
Oh,
Some of you may have heard of Phil Plait.
nice book.
He's pretty active as a astronomy advocate guy. Right, he wrote a book. He did the Bad Astronomer book. He does a lot of YouTube videos. He's pretty active in the amateur / professional astronomy community. I got an email from him, and it says, very interesting. I couldn't find anything in the Simbad database, which is a pretty extensive database of stars and whatnot. He also had ties to the Hubble. He looked to see if there were any Hubble images of this area of the sky. He starts to talk about maybe being able to see the star, not sure. He says there's more Hubble images due to come out soon. I don't know if the field of view would cover your star. So he wanted to be kept in touch with what we were finding. So it was pretty cool. At the time, I'd never heard of Phil Plait, you know, but anyway, I certainly know who he is now, but it was interesting to get an email from him. There it is, June 29th, which is the same day that I posted that website on the internet. Next up, I get another email from a guy named Brian Skipp. He's a professional out in Lowell Observatory in Flagstaff, Arizona. And he had an interesting take on this. He sends a message that says the motion of, he did some measurements, the motion of 7.5 arc seconds over the 40 years leads to a proper motion of about 0.18 arc seconds per year, which is interesting because that 0.18 keeps it under the survey of 0.2. So these Lowell observatories and some of these other highfalutin places do surveys of star motions, but they have a cutoff of a minimum of 0.2 arc seconds. And we're slightly below that. So the star's moving below the rate that they use to look for these things that are moving. He says that's probably why it's not found in the catalogs. Other than that, it's most likely a nearby K-type dwarf star. That's important to make a note of. K-type dwarf. If you know anything about K-type stars, can you give me an example of a K-type star?
Aldebaran.
Aldebaran is one. It's kind of like a yellowy red color. The other one that comes to mind for me is Arcturus. If you looked at Arcturus, it's got like a yellowish hue to yellow orange almost. So along that line of the spectrum, so he thinks it was a K-type dwarf with a modest motion relative to the sun. He says it's a good exercise in paying attention when you take CCD images and being receptive to anything that could show up. He says, additionally, he also checked the Lighten 2/10 catalog, 59,000 stars. It wasn't in that catalog, nor in the LIC proper motion survey, which has a couple 100,000 stars with no cutoff in motion. And it wasn't found on that list either. So we stumbled on a star that they hadn't discovered yet as one that had enough proper motion to be detected. Yes, sir.
I got a question though.
Yeah.
If you were to take an image and then wait 5 years and take another image, well, that would be 1 arcsecond, not 0.2. So why aren't they looking? Why is their cadence 1 year? Why isn't their cadence larger?
That's a good question. You're right. After 5 years, it would move 1 arcsecond, right? 0.2 times 5, or 0.18 in this case. It might take a little more than 5 years, so that they could detect that 1 arcsecond of movement. I don't think they were going back and resurveying the same part of the sky again, which is going to bring us to Gaia in a few minutes, the spacecraft Gaia out there. We're going to go to that, and then we're going to have some more hardcore answers. But anyway, we're still working with this. It's still under the radar for all these professional observatories. Again, this was June 29th. I got this message the same day that website hit the internet. So it was pretty cool to reach out to these guys on the very first day that this thing was posted. Soon after that, I heard from this team. Some of you may have visited this place, you know, out in Cambridge, the Harvard Smithsonian Center in Cambridge. I think that's the 60-inch reflector at Oak Ridge, right? Have you made a field trip over there?
It's big. Yeah, Mike's kneeling down.
We know that guy.
I figured, I knew there'd be connections in this group. I knew.
Yeah, that's right.
Right? So there's some guys here that you're probably familiar with. I got an email from, I'll show you. Joe Zajac.
Oh, yeah.
So he sends back a message. He says, Robert Stefanik, who's the director. I think he's the guy on the left. I think that's the director. I'm not sure who Joe is, if he's in that picture. But anyway, he sends this email. It says that they have reviewed the image.
Absolutely.
They agree with the motion, 8 seconds over 44 years and about magnitude 15. They think it's probably a faint M-type dwarf, and it's nearby and has a high proper motion. So he's sending these emails on to another guy to analyze this further. So it's interesting that Brian Skiff said that he thought it was a K type, and this guy thinks it's an M type. They're next to each other in the spectral class of star temperatures and whatnot. I'll show you what I mean by that. The stars that burn really, really hot, extremely hot, are blue, and they're at the O end, and then they become a little bit whiter, B, A, F. A sun is a G type of star. K, we talked about Arcturus and Aldebaran being K type stars, and M, such as Betelgeuse, is a red colored star. They're a little bit cooler, is what I'm trying to say. And these two astronomers, one said maybe K, one said M, but it's important to note the color here that they thought that star was going to be. Like an orangey red color, in other words. So moving on from there, I got a phone call. Remember when you had a landline in your house? I got a phone call. The phone rang when I got home for work, and I pick it up, and it's this guy, Gary Saronic from Sky and Telescope. And he asked, you know, is this Steve? And I said, yes. He says, hello, and Gary Saronic from Sky and Telescope. I'm like, oh, I know who you are. I've been subscribing to your magazine since I was a kid. He says, yeah. He says, I'm interested in doing a little story on your, I stumbled across your website and the news group. He says, I'm interested in doing a little story on your discovery. And I said, well, of course. So I gave him a little 5 or 10 minute interview. And he wrote up the story, which appeared in the October of 1999 Sky and Telescope. So it's just a one page, there's a couple of paragraphs there, but he used my little diagram and calls it a serendipitous discovery. You know, total luck. These guys just fell into a pile of, you know what, and found this star moving across the sky. But it was pretty cool. And for me, it was coming full cycle because I showed you at the beginning how I made my very first discovery by using Sky and Telescope magazine when I discovered Venus in 1978. You know, so I go from this kid at the library flipping through this magazine to actually having a little article in this magazine. It was pretty satisfying. I was pretty thrilled with that. So that was October of '99. We still didn't really have any answers. The interest kind of like came upon a dead end. You know, I wasn't getting any more feedback from the pros or even other people saying like it went as far as it was going to go. So I've never forgotten about it. I certainly have not forgotten about the star. I can find it in the sky pretty easily. This is the earlier image that you saw, but I did get out there with my telescope in 2006 and take a little image. By now I'm into CCD imaging myself. I used the Meade DSI, which is a pretty basic camera. Put it on the telescope and took a picture of that star in 2006. You can see it's moved a little bit north of that line between the quasar and the star. You know, it's not quite in line like it was here. Can you see that from way back there? It's moved a little bit in the direction that you expect it to be moving. So this was 2006, 7 years after.
But it also seems to have moved further away from the.
Yes.
That might have to do with the bloatedness of these, you know, these being really bloated.
Okay.
Yeah.
You know, and these being a little bit crisper. You know, I think maybe that makes it look, they look closer together here.
Yeah, Steve, what I was thinking of, that perhaps that's evidence that it's not a companion, that it is just a star field.
Yeah, it doesn't look
star
like it's
in the-
curving around, right? Yeah, I see what you're saying. It doesn't look like it's gonna loop around, but we need more time. So fast forward to this past May, I had my 5-inch refractor on the mount, and I have a S-big CCD camera by this point, and I put the CCD camera on the mount and I zoomed it to that area of the sky. I really should have used my 11-inch scope instead of the 5-inch to really zoom in on this area. In this star field, the little V is right there. See that? I zoom in on it. I know it's tough to see, but when I zoom in on it this past May, it's moved up quite a bit more than even 2006, 1999, 1955. So it's moved, you know, it's still moving, it's still going in the right direction, it's still there. But this is 23 years of motion. So now I need to talk about how far or how little it moves over a period of time. A lot of people are familiar with the double star Mizar and Alcor. It's a naked eye double star in the handle of the Big Dipper. If you can't see it naked eye, you can certainly see it with binoculars. The second star in from the handle of the Big Dipper. There's 2 stars here. Through a telescope, it looks like this. It's Alcor, the brighter star. 12 arc minutes away is Mizar A and B. And those are pretty easily split with low power telescope. It's a pretty beginner's type of double star to cut your teeth on. They're 14 arc seconds apart, I think. Is that right? 14 arc seconds? I think that's what it is. Yeah, I wrote it right there, 14.4. So to give you an idea, I did some backwards math and figured out it would take 90 years for the star that we've been talking about all night to travel the distance across the sky from that star to that star. And when you look at that distance in a telescope, it's not much. It's really not that much. Another example that I can give you to explain the distance traveled is I can hold up one of these, a CD. A CD, if I were to take this CD and move it a distance of 24 miles away, and you could look at it with a telescope, its width would cover 1 arc second. just to give you 1 arc second of space, 24 miles away this has to be when you look at it with a telescope. So if you take the distance that this particular star moves in a year, 0.18 arc seconds, you would have to take the CD and put it 150 miles away and look at it with a telescope to see the distance covered by the star from one side to the other over the course of a year. It's a really small distance that this star travels per year. I just wanted to give you an idea of the sizes we're dealing with here. So enter the Gaia spacecraft. Here we go. Yes, sir.
Kick into it a little more. If you were to talk to people capable of doing spectroscopy, and they could get some spectral lines on the 2 stars, the moving star, plus what I'm gonna call its companion, its parent star.
Yeah.
If you could check those spectra and they were identical, they would be in the same distance relative to sun.
Right.
If they're at different distances, then you've got a calibration of how far away the moving star is relative to that other.
They could tell if one is moving towards and for, to and fro
Yes.
at the same time.
Yes.
Yeah, that's interesting. But Gaia, its mission was to catalog millions of stars to get their positions, their magnitudes, and the directions that they were traveling. That's the mission of the Gaia spacecraft. It was launched by the European Space Agency, and its goal, as you can see there, is just to create the largest, most precise 3-dimensional map of the Milky Way by surveying of 1%. They only say 1% of 100 billion stars, but that's still a billion stars, right? It's still going to survey a billion stars in our neighborhood, and it's going to get the motion of each star around the galaxy, and then it's going to observe each star an average of 70 times over 5 years. So it's going to keep coming back to talk about your point, Steve, about why it didn't come back in 5 years and see that it moved an arc second. You know, these guys with the observatories, they didn't come back and look at it to see how much it moved. But Gaia is going to do that. It comes back 70 times over 5 years to record the brightness and the position of each star that it looks at.
Do you know what the limiting magnitude of the Gaia system is?
I don't know that, but I do know that our star was included in this catalog, which was pretty exciting. I'm getting to that. So make some popcorn.
I think it's 21.
Something like that.
Okay.
There's a little more information. Oops. A little bit more information about the Gaia spacecraft itself. Launched by the European Space Agency. It's out at the L2 point. What else is out at the L2 point? The Webb, the James Webb Space Telescope is out there. So we got the sun on one side, the Earth in the middle, and the total opposite is the L2 point, where it's a kind of a comfortable place for these distant probes to rest. So hopefully the Gaia spacecraft won't crash into the James Webb spacecraft out there at the L2 point. It's the weight of a small vehicle. Some of its data, blah, 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 launched in December 2013, and it's, do astrometric and photometric and radial velocity studies. So it's basically just making a real detailed star chart of all the stars that it can see out there. It releases its data in waves. So a Gaia data release is a big deal, and it releases them every couple of years. It'll unload data for another, 200 million stars. The one for the particular moving star that I've been talking about was released in December of 2020. So not even 2 years ago, the information was dumped on this particular star that we've been talking about. So I have all the facts and figures on it now. It's got an official designation, a precise location of where it is. At least it was when they measured it, right? Because it's still moving. It's magnitude 15.7. I failed to mention earlier that Dan and I, after we had seen this moving star on the CCD images, we went back to try to see this visually, and there was no chance. There was no chance we were going to see this star. We could see the quasar, but there was no way we were going to see magnitude 15.7, just beyond our range. And the proper motion, they actually downgraded to a little bit slower, to 0.16 arc seconds per year. So it's a little bit slower moving than we thought it was. The quasar next to it, the one that we had originally set out to look at, has this designation, magnitude 14.6 is what we thought. and its distance is 7.8 billion light years away. So we got pretty precise detail on both of those objects. Finally, I'm winding down here. There's a pretty cool website that comes out of Frankfurt, Germany, called the Frankfurt Quasar Monitoring website, I guess it is. So when I plug in the designation for that galaxy, this is the designation for the galaxy that we were studying, I get a few websites, but this was the best one. And it basically just gives all kinds of data for that galaxy that we were looking at in the constellation Hercules, quasar, the redshift, which equates to 7.8 billion light years, how many megaparsecs it is, the magnitude, blah, blah, blah. It gives more information. It goes on. They actually, I'm going to try to zoom in here if I can. They actually did this. One of the charts that they used to show the quasar. Look at that. You can tell which chart they used. Right? Which one did they use? They used the old one from 1955, right? When the star was way down here. That's the first image I showed you from Mount Palomar. See, there's the quasar, and there's the star way down there. This is an old image, Deep Sky Survey 1. So they used a really old image to show the location of this, this quasar. Then they show the magnitudes of some of the comparison stars there. And then, one second. This was interesting. Then they showed a color chart of the star, which I don't have anything in color up to this point. See, they show a color chart of the star.
Yeah, it's colored.
All right, see that? And look, the star has moved. Now it's back up into position where we first saw it in 1999. It doesn't say the year here. They give the name of the guy that took the picture. But it doesn't say what year that it was taken, so I'm going to zoom in on that in particular. Show you something. So look at this. I was fascinated when they showed the moving star that Brian Skiff and Joe Sajak had said was a K or M type star, meaning that they thought it was going to be orange. And sure enough, when it shows up in their picture, it's an orange star, just as they had conjectured, as they had guessed that it would be. This to me looks like it was around 1999 again, you know, when everything's in a nice straight line like that. But I was pretty excited to see that it definitely looked orange to me.
And your quasar looks blue.
The quasar?
Yeah, it does.
Yeah, it does. I suppose a lot of them do look blue-white, don't they? Kind of look super hot, super luminous.
Yeah, super luminous, that's the point.
Blue-white, I think. So I'm not really surprised by that, but I was thrilled to see that that was orange. So moving on from that. This Frankfurt website, they also took the liberty on this upon themselves to point out, they did the same thing that we did, 1999. They said, hey, look at this. The Palomar image, 1955, shows that star down here. And then over here, in November of 2011, the star is moved over here. And this one was taken by the Taunus Observatory, I think is in Germany also. 60 centimeter or 24-inch reflector. They put side-by-side images, much like we did, you know, quite a while before they did. So I'm seeing this, I'm saying, huh, imagine that. So I dig a little further. I get to their notes here. I'm just going to read what it says at the bottom here. I'm not going to expect you to read this, but they talk all about the quasar notes and blah, blah, blah. And they talk about down here, it says some 45 arc seconds to the west of the quasar is a 15.7 magnitude proper motion star that can be seen in the images above. So they show the comparison images and they showed the star. It's designated as blah, blah, blah. So between March of 1955 and November 2011, its apparent position had changed significantly. And then they document it. They say they blah blah. They they put their stamp on it. It's like, oh, you guys, I felt like a little bit violated, but then I read the literature. I read the literature at the end of the article. And I read it really carefully. And I see one of the credits that they give is right here. The Gary Saronic article, 1999 Sky and Telescope, a serendipitous discovery. So they did give us a due credit right here by putting that article in their literature when they posted a picture of that moving star. So finally, I'm going to show you that star in motion using a planetarium program. Hopefully I can do that. I'm going to see how this works. Let's see, I'm going to exit here. So what I'm doing is I'm setting this planetarium program. This is called Guide. It's very archaic. It's an old program. And what it shows you, oops. Oh, now I got an echo. So very quickly, this is where the quasar was. You know, in 1999 when we made the discovery, and this is where the star is located. And I'm going to set this thing in motion. Every 1 second is going to count off 1 year of time. So you're going to see how it moves along. So every time you see that blink up there, another second of time is going by, another year of time goes by, and you can see that star creeping northward. When I first used this program on this star in 1999, it didn't have the capability of knowing its proper motion, but with some of the new data that's been downloaded from Gaia and some of these other survey probes, they now know the specifics of where the star is moving and how it's moving. So now we're up to the year 2072. You know, it started in 1955 down here.
So that's definitely not a binary then.
No, it's continuing on a straight path, either in front of it or behind it, you know, but it doesn't seem to be tied to that star at all. And it's interesting that none of the other ones really seem to be moving much in the next 100 years.
The quasar moves.
What's that?
The quasar moves every like 5 ticks.
The quasar moves every now and then.
Yeah, it does.
Yeah, just a little bit.
That's really strange.
Here it is. It's going, wow.
Why is it moving like that?
I don't know. I don't know how much faith I put in that. It's really you know, this program is pretty old, but it does show the motion of the star. Now we're up to the year 2065. So another 140 years from now, it'll be way up there. So anyways, that's my little presentation on the backyard.
Yes.
Excellent research.
Yep. Oh, okay.
Oh, that's excellent. That's amateur astronomy
Right.
at toward the apex. Well, boy, that was pretty thorough, but Mr. Hendrickson has found a question.
The guy at DR3 has parallax data in it. We'll be able to find out how far away this is.
That's a good question. I don't know. I thought he's asking about the parallax. How far away is this star? That's funny. That didn't come up as any of the Gaia information. You would have thought that it would have been part of that. You know, if they're surveying the same star 70 times over 5 years, you think they would figure out how far away it is. You know, but
Unless
honestly,
it's
I never
exceptionally
came
far away.
across that. That's a good project for you, Jim.
And the other thing is, if you know the spectral type, okay, say it's a K2 star, and you got the apparent magnitude,
Right.
then you can get the absolute magnitude and can figure out how far away it is.
Ah, yeah. Interesting. I don't know what the apparent magnitude is. I know the visual magnitude.
Well, that's what I meant, the apparent magnitude.
Well, I mean the absolute magnitude rather. You know, to tell us how far away it is.
No, but they should. No, you don't.
From the spectral type of the star, they should be able to determine what its brilliance appears versus what it would be at 33 light years. So you could calculate the absolute magnitude.
Yeah, you're right.
I only started
See what you
revisiting.
started?
That's another good project. I only started revisiting this past July. I gave this presentation to a club that meets in Situate, Mass, of all places. The South Shore Astronomical Society up there in Situate. I gave this as a monthly talk, and it only got me into even finding the guy. I had downloaded more information about the star, and that Frankfurt quasar website existed. So a lot of this is fairly new to me. It wasn't available back in 1999 when I was digging into it. So yeah, I can continue to run with this and look up some of the things that you mentioned, parallax, distance, and what you mentioned about spectroscopy. Yeah, that'd be a good project.
Yeah, because if you look at it spectroscopically, you might discover it's a double.
Right?
That'd be great.
With one eclipsing the other. Oh my, anyway.
It's going to explode any day.
Not enough mass. Cool. Any other questions? Oh boy, that was great. Well, thank you so much.
Oh, you're
Steve.
welcome.